Okay, so the sum of the interior angle, do we know this off by chance? Elizabeth? It's 180. 180. You guys gotta watch darts. You gotta go watch it. You don't get what I'm putting down there. Okay, so it's 180 degrees. All right, which means here are your Greek friends here. We've got theta, phi, and alpha. That means theta plus phi plus alpha equals 180 degrees. Now here's one for you. I don't know if you know this one or not. I'll let you get caught up. Okay, the sum of the exterior angles of a triangle is always what? Do we know that? This one is less common knowledge, I think. Yes, Elizabeth? It is 360. It is 360. Okay, and I'll try and prove that for you, in case you're just wondering. This is random, okay? So let's pretend here for a second. It looks like it's equilateral. It might not quite be, but we'll call it an equilateral triangle in the form of some little hashes, okay? So if each side length is equal, that must mean each angle is equal. And so what does that make each one of these? Just out of curiosity. Full well knowing, okay, and this is a good little chance here for you. Full well knowing, if we call this like theta, right? Theta, theta, theta. We know what? Because we just did it above. Again, good opportunity to review some linear skills here, right? We know theta plus theta plus theta has to equal what? Elizabeth? 180. And so how many thetas do you have there? We got 3 of them. We're collecting like terms. So 3 theta is equal to 180. How do you get theta? Remember, theta is just a letter. Don't worry about it. It's just a letter, just like x or y or z. Merc? Divide by 3. So theta is going to equal 60 degrees. So in an equilateral triangle, like what we've drawn there, each angle in the corners has to be 60 degrees, because 60 plus 60 plus 60 is 180. Is everybody okay? Now, I know that hasn't answered our question about the exterior angles, but that's what we're going to do now. I'm going to prove to you that that's the case. Okay, so we now know that theta is 60, 60, 60. Okay, and then we're going to use a little property from the other side of the page, the supplementary angles. So if I asked you, what must this angle be on the other side? On all of these, what has to that be? How many angles are in a straight line from here to here? How many did I say how many angles are in a straight line? Is that what I said? Wow. How many degrees are in a straight line? 180. So how do I figure out this arch here, this angle there? We'd have to go 180, take away the 60 that I know is on the inside. Would everybody agree? So that's 120 degrees. Don't forget your degree symbol, sir. Okay, so that's 120 degrees, and how many of those do I have? Well, it looks like I've got one there. There's another one. Here's another one. And so you got to ask yourself, okay, well, what's 120? I'm counting all the degrees or like around the outside of this triangle. I got 120 plus 120 plus 120. What's that look like? When you add that up, what do you get? $360. Now, it's not just because it's a special, I picked a special case of a triangle, like an equilateral, just to be easy, but it doesn't matter. It doesn't matter what kind of triangle you have there. You know that no matter how I break down these two angles here, if it's 60 or if it's 40 or 30, whatever it is, you know that the two angles have to add to 180. And regardless, you're going to end up with all three of these angles here, even if they're all different, they're going to add to 360. Because they're supplementary of one another. Is that all right? Anybody have any questions? Questions, comments, or concerns? Okay, so let's go down. If you had to take a guess here, just a guess out of almost thin air, I suppose. Using two triangles, what can you conclude about the sum of the interior angles of the quadrilateral? So using two triangles. So I think before I even ask you what the answer is, let's draw two triangles on here. I don't know, I'll do something like this. There's two triangles. What has to be true about a triangle? What do the angles have to add to on the inside of just a triangle? Elizabeth? Okay, so if I have 180 degrees on this one, and I know that there has to be 180 degrees on the other one, what must that make all the angles add to for the inside? (180 plus 180) is? It's only, we got all those angles in there. You know, if each of those angles has to, like each triangle individually has to add to 180, then all the angles have to add up to 360. Right? Because you broke it into two triangles. Right? Each having 180 degrees. Right? So you're going to have, say, each triangle there. Now this next one, I just kind of took a guess at the angles. You could help me if you wanted to, just by eyeballing it. Okay, I'm going to start with an easy one. Okay, the sum of the exterior angles, I suppose, is what we're trying to figure out here. I'm going to start with the easy angle in the top left corner. I'm going to call that 90 because it looks pretty close. Would everybody agree? So I'm going to draw myself a little square in there. And I know if I have 90 degrees in one part, what's the supplementary angle to 90 degrees? Knowing that these two have to add to 180, what must this other side be if one side is 90? Yes, it also has to be 90, right? Because 90 plus 90 is 180, right? So I know that the outside here is going to be 90. And again, I don't think it doesn't really matter what you label each of these, just so long as you're like taking into consideration this 180 rule. It doesn't matter what you call this. It's just that the two angles add to 180. Okay, so I don't know. What do you want to call this one here? This next angle to the right. If you had to call that how many degrees would you take a guess of that being? Colson? 100. Yeah, 100. 100's a good guess. But if that's 100, what must this be? Yes? 80. It has to be 80. Because again, it has to add to 180. Okay? And we'll go around. It doesn't really matter what you call each of these. Right? And again, most of the time when you see these questions, they're not drawn to scale. Okay? They're just there and they slap information on it. So you got 70. I just call it 70, which must make this one 110. Okay? And then the last one we'll call 100 again, I suppose, which makes this 80. And so if I were to check all these outside angles, I'll highlight them. There's 90, 80, 110, 80, if I add all those together, that has to equal 360. How much time we got? Oh, okay. All right, we'll finish this up after break, okay?